now let's take a step back. Any interview questions that folks have been through, which involved arrays? 1D array. Let's do 1D arrays first. Anything on 1D array?
Find majority element.
Find majority element. Very complicated question. So I'll take a step back and we'll come back to it. Find majority element is a very classic question. We'll come back to that.
Median of two sorted arrays.
Median of two sorted arrays. Okay. So given a sorted array, how do you find the median of a sorted array? Single sorted array.
The middle array.
Yeah, it could be even or odd. Yeah, if it's odd, it's middle.
Mm-hmm. So you've got a sorted array, okay? The array could be of even length or odd length. So if the array is even length, then there are two middle elements, okay? Median is defined as the
element that divides the
array into two equal halves. So essentially, in this particular case, it will be the whatever like the I element and I minus 1. You just need to make sure that you take the average of the two elements. That's mathematically defined as a median.
Right.
So let's, for simplicity's sake, let's assume it's odd. Okay? If it's odd, then essentially that's what it is, right? So you've got k elements here, and you've got one element here, and somehow your array is essentially 2k plus 1. So if you have a single dimension array, which is already sorted, finding median is like piece of cake, nothing else. What do you do? How do you find the median of a single median for two arrays which are sorted? Two sorted arrays, median. How do you find out?
Can you give an example? What does that mean?
Oh, sure. So let's assume this is 1, this is 3, 5, 7, 9. What's the median of this array?
5.
5, right? Okay, 2, 4, 6, 12, 13. What's the median of this array?
6.
6, right? What's the median of the combined array?
Oh, okay.
5 plus 6. Yeah.
5 plus 6.
5 or 6.
1, 2, 3, 4.
No.
5.
6 plus
Let me do
5.
this. What's the combined? What's the median of the combined array?
1, 2, 3, 4.
What's the combined array look like? Let's do the combined array first.
1, 2, 3,
So
3,
1,
4, 5,
2, 3, 4, 5,
7, 9, 12.
7, 9,
12,
12,
13.
and 13, right? Unfortunately, this is
Even number.
even
4
number.
plus 5.
Fine. So I'm going to, yeah.
13.
So which is what? Which are the two
4
numbers?
plus 5.
4 plus
4.5.
5. You are right.
Okay.
4.5.
Perfect. Worked out exactly the way I wanted it. Okay. So the median of this is actually 4.5, which is the average of 4 and 5. Now, just because it worked out like this for this example doesn't mean that that's true. Right? Why is if I had 11, 13, 15, 17, 19, that's not the same, right?
That's right.
No, you see like
Then the median is simply shift because
3 and 4.
so this is 2, 3, 4, 5 are all here, and then
You don't have 5.
There's no 5.
You don't have 5.
I don't have 5. 2, 3, 4,
11,
11, 12, 13,
11,
13,
11,
12,
12, 13, 15.
13, 13, 15, 17, 19.
So now the average is 12.5. And the mean is 12.5 in this case. The median is 12.5. So, how do you find the median of two arrays?
If you have a luxury of additional memory, you can have 2 pointers on the first array and the second array and see whichever is bigger, not smaller. Put it in this third array and walk the pointer up to the end of the two arrays. Then you have a sorted list of elements. At the same time, you have the length of the final element, and then you can have, like, since it's an array, you can find the median value.
To find the median, you need to, do you really have to store these values?
No, you don't.
Then why do you care?
I probably
Let
can.
complete this thought. Go
Right.
ahead. Like, I understand what you're doing. What you did is like you have a pointer here, you have a pointer here,
Right.
right? So what do you do next?
So move on to like drop
So
the
you
two-
know that 2 is small.
small, right?
So you just move 2 and now you went to 3.
The other one, right?
Now like 3 is small. So now what do? You went to 4.
4, right? Exactly.
Now 4 is small, so you went to 12.
11 is small.
11 is small, so you moved to this, right?
Right. Right.
So now when you did this, before you did that move, how many elements have you seen so far?
4.
1, 2, 3, and 4 elements are done. So this and this,
Fifth.
one of them is the fifth element,
Yeah.
and we don't know if this is the sixth element or this is the sixth. We don't know that yet. Like we know one of them is the fifth element,
Right.
right? And now that we know that this is the smaller one, we go here and we know one of this is the sixth element.
Right.
And since this moved out, we know that this was the fifth element and this is the sixth element.
Yeah, that was like.
And that is enough, right? So you don't need
Yeah.
you don't need to store the array. What does it mean? What are the things that you found out? What do you need in order for you to do? How did you figure out that fifth and sixth element, average of fifth and sixth
The combined
element?
size of the array, we need to know that.
Total.
So we need to know that this array was size 5,
Five, yeah.
and we need to know this array was size 5. So the combined array is size
10.
10, which means that I need to make sure that
The fifth
or
and
12,
sixth.
right?
Fifth and sixth.
4 plus 4, 8 plus 2, 10. So essentially 0, 1, 2, 3, 4 and 5, right? Index 4 and index 5
Correct.
is what I need to get. The fifth and the sixth elements, or index 4 and 5 is what I need to get to. So do you need to store the target array?
So yeah, I mean, first approach, there is a memory overhead, but then I think running through the array, you don't have to run through the array a couple of times, because for the first array you have to find out the length. The only way to do is like run through the array. Then again, it's another array, you run through it. So there's a execution overhead. If you don't, yeah, that was definitely another solution that I wanted to say. But this is like you don't have an execution overhead. If the memory is higher, you have a luxury of having memory. The first approach is better. But if you don't care about the execution, like for example, there could be a million of number, and in that case, you probably might.
And in both scenarios, you're doing exact same operation. You don't have to store the 2s, the 3s, you don't
Right.
have to store them.
But you have to know the length of the array, right? For
You
both
will know the length. So one of the things we know, arrays are fixed size anyways. So you better know the
Oh,
length.
the
of the
probability.
array.
Okay.
You have to,
Right.
right? Typically, you would know the length of the array, right? So that's where you are. So what is the big O of this particular operation?
Space is order 1.
One.
Space or 1 because you're not actually adding any extra space. What's the length? Time.
Time, order n.
N by
Order n.
N.
Order n.
Can you be more precise? Like you're actually essentially you're only going as far as absolutely necessary, no more. So if the final array size was n, you're actually just going n by 2, maybe plus 1, right? Can you do better than that?
I think since it is order, we can try to see if we can, when we are, basically essentially we are discarding first 4 elements. So if we can use a binary search technique to discard from both arrays, that
Like log n, is that what you're saying? If we can do it in log n?
There is a log n.
I think we can do it in log n.
Huh?
No, but you might be able to do it in log n.
The log of m plus n. basically.
So let's take a step back. So this approach that we just talked about, is it super clear? Any questions on the first approach? Would people be able to code it up? Like we're not walking through the code here in this particular session, but if you are even like 99% sure and not 100% sure, I would recommend that go write down the code, because it's actually it's a good exercise to know how to find the median of 2 sorted arrays quickly. And because the devil is in the details, so there's like cases where one is odd, the other one is even, or both are even, both are odd. How do you actually figure out what's the right way to what's the right way to manage this, right? So please make sure that you do that. Now, how do you actually find out the median of 2 sorted arrays in a time complexity which is less than O of n?
So we
Better than
know
of
the
n.
middle of the first array and the second array. So we compare that one.
Uh-huh.
We go from the middle and we compare 4 and 15. And so then increase the second array. We know 4, next element will be greater, 12. And this one will be lesser. Instead of going from the beginning, going from the middle.
It's still the same because like if you have like one array is really small and the other array is really big, you have the same running time from both sides. So it's still the same even though you run in the middle or in the beginning.
So
You run like every single element, right?
your
So-
big O should essentially, the way you want to calculate is the worst case scenario. Construct given whatever algorithm you come up with, I should be able to construct, like no matter what data set I construct, your algorithm should be fast enough to run in whatever time that is, right? So how would you pick that? So let's take a step back and try to, how many of you actually understand how to actually find an element in a sorted array?
Binary search.
Binary search. And how do you do binary search?
Go to the middle element.
Go to the middle element.
Go to middle element. Then what do you
And
do?
discard one half. I mean, either the first one or the second, depending upon what you're looking for.
Okay. Discard the left half or the right half, depending on. I mean, either you found it, you're lucky,
Yeah.
or you discard the left half or the right half, and you're done with it, right? So it makes sense. Now, if I were to take the same approach here somehow, right? So, okay. And it doesn't even have to be the middle element. It doesn't even have to be the middle element. The middle element is preferred because you're starting with something that is more meaningful.
Yeah.
So what you do is that now you have picked up 15, right? Now if you binary search 15 in this, where do you find it?
You won't find it.
Okay, what do you get?
The last element.
You get the 13, but you won't find that.
Okay, you got the 13 elements. So essentially, what does that mean? You've got, what is your goal? Your goal is to find a number k such that there are 4 elements less than k.
Mm-hmm.
Okay? And then I want to find another element which is essentially L such that there are 4 elements greater than L.
Yes.
Okay? And you want to find such that k is actually has to be
Equal to
less
L
than
or
or equal L. That's all you want. This is what you want to do, right? That's kind of what your goal. Your goal is to find this. Correct?
Yeah.
Absolutely.
Mm-hmm.
So now, is 15 a candidate for k? No. Why not?
Because there are not 4 elements which are less than, greater than 15.
Okay.
There
So
are only 2 elements which are greater than 15.
my k is actually between 2 and 19. Correct?
That's correct.
My L is between 2 and 19. Correct?
That's correct.
When I began, just looking at the first 2 elements or last 2 elements, I know this, right?
Mm-hmm.
So now that I looked at 15 and I did a binary search for 15 here, I found, what did I find? I found that 15 is essentially more than 13. So I've got how many elements less than 15? 1, 2, 3, 4, 5, 6 and 7 elements less than 15. So not an, and how many elements greater than 15? 2. So which means that my L cannot be more than,
It has to be less than 15.
that I know, okay? K, also same thing, right? Because of this reason anyways.
Yes, that's correct.
I haven't changed anything, but that we know. So we got that anyways. So this is all we figured out. Then I do 4, I binary search 4 on this one. I'm just going to make ones. Oh, no, I can't make that change. So no, not here. Okay, so I got this. So what does that mean?
You will get 11. You won't find 4 in there.
So what does that mean?
So it has to be between 11 and 15.
Why not? Yeah,
4 and
4 and
4.
not 11, 4. 4.
Okay.
That's all I figured out, right?
Yeah.
Okay, so now at this point of time, what I found out is that my answer is essentially on right side of this and left side of this. That's all I know.
That's correct.
Okay? So now pick an element that is in the middle of this array. Pick an element that's middle of this array. So I'm going to pick 13 as my next candidate and 12 as my next candidate. Unfortunately, that's the answer. But the same logic would continue to work. So if I pick 13, what do I get? How many elements are greater than 13? In this
Only one.
block alone, because I already know that there are 2 elements greater than this and whatever. In this block alone, what do I get?
1.
So 1. And if I do a binary search of 13, I got this point. Right? And on the other hand, duplicates makes it a little harder. On the other hand, if I look at 12, if I binary search 12, I get this. So I got 12, which has got like 2, 3, 4, and 11 are less than this. So I got k is 12. Correct? So now how many binary searches have I performed?
4.
Mhm. So is that, so how many would I typically perform? In the worst case scenario, how many binary searches? do you expect?
into log n.
Is that better than n?
Yes. Definitely.
Are you sure?
Complexity log n is better than
No, but we got n log n.
n log n.
How is it n log
Then
n?
n is greater.
Right, because log n is
Why
log
do you
n.
go to all the n elements? N is the least. It's like half of
What is n? How many times did I have to do this? I did it 4 times to get the answer. How many times did I have to do it? Imagine large data sets. Imagine I have like millions of rows, millions of elements in each array. How do I actually figure out where the median looks like?
you add that log n plus 3?
How many times will I actually do that?
It's log n, log the, okay, the single length, also log n.
No, so let's assume that this has got n elements, this has got n elements as well.
Okay, so the m
Total of
is
2n.
the m is also log n.
Yeah, log
This is also log n?
Yes.
Yeah.
Log n.
So
Log
2
n
times
times
log n is
log n.
log n.
So you're doing binary search on the first one, which is login. The second one is login.
Yep.
And you're doing it like
N by 2.
the max number of times you're going to be doing on one.
The second one
So the
is.
second binary search is log n by 2, right?
It is still log n, I believe.
What?
Because you've done the first binary search is for the entire array.
Correct.
After that, your second binary search, you've isolated one half of the array, and you're saying I
I
want
found
to search the
15.
next half.
I'm trying to find 15 in this array.
Yeah.
Correct?
Yeah.
And it's either you're looking at the whole array, you are looking at the whole array anyways. So that's log
That's the
n.
first time.
Right? First time. Once I have found a location, so let's assume that I'm not going to put numbers here. This is what we got. Okay? So I found this element mapped out to somewhere here. Okay, that's what happened. So, and this element essentially mapped out to somewhere here. That's what we got. Okay? So this was my first median, and this is what I got. Okay? Now when I'm doing when I'm trying to find my K's and L's, I'm trying to find the values that I'm trying to find, that information is here, right? It's left of this
And right of that.
and right of this. Correct? So now I'm going to pick a median that's here. I'm going to pick a median that's here.
That's what
Now my space is actually n by 2 at this point of time, because more or less it's less than n by 2 anyways. At the worst case, I'm trying to find n by 2. So when that happens, what am I getting? Like what's the, so the question that I have was, what is this constant? Like every time it's going to be log n anyways.
It's 2 log
because
n, I think,
It's
which comes up to log n.
at the next point it's going to be, I'm probably going to do log of n by 2.
Yeah, so you'll do log of n plus log of n by 2 plus log of n by 4 plus
Which
log
is
of
what?
n by 8.
Log
which
log
is
n?
2 log n. Which is log n.
Which is log n.
Right? Something like that.
Yeah.
Because at all points of time you're going to eliminate at least half the space anyways. So this
It won't
is,
be 2 log n, right? I mean, log m by n is log m minus log n, right? So it'll be log n plus log n plus log n plus log n and minus log 2 minus log 4, I think. Right? So it will be n log n minus of log 2 plus log 2 square, log 2 cube.
no,
So
how
that
many
will be,
elements are there?
N.
So log n,
2 n
you
Okay.
might go till what?
2 n anyway.
2 raised to.
This will be log n.
Login.
So every time I'm reducing n by half, how many elements will be there? Log n elements.
Login.
Log
Yeah.
n. Eventually you'll reach a 1, right? That's the thing.
Yeah, yeah. How many times? So if this were to be like
It will come to log n by n somewhere, so it should come all the way to 1, I thought.
correct, but how many elements will be there?
Log n.
Log n elements will be there, because every time I'm reducing it by half, right, by a factor of 2.
Yeah, so there'll be log, okay.
There'll be log n elements. If I have, if n were to be 1024, there will be 10 elements. There will be one for n by 1, there will be n by 2, n by 4, n by 8, and so on, right? 16, 32, 64, and so on. There will be 10 elements. So essentially, you will have log n minus, what do you have?
It'll be n log n, right? Why will there be log n log n?
How many elements do you see?
Oh, okay. I think that's where I'm losing it, okay.
You won't see 1000 elements, right? If n were to be 1024, you will only see 10 elements here. You won't see 1000 elements.
Okay.
Right? That's what you got. What's on the minus side? Minus, you got log of 1 plus log of 2 plus,
Log of 4.
right?
What's the last one?
Log n.
Log n to base n is 1.
Log n. Like it'll have like 1, 2, 4, 8, 16, so on and so on, and then finally it will go to log n anyways at the end of the day. Right? So I'm trying to see what this is
That
actually.
you come to 1 plus 2 plus 3 plus 4, right? Because log 2 to base 2 is everything, log n to exponential, the exponent comes down and the same bases cancel out, so it will be minus of 1 plus 2 plus 3 or whatever, it just
I
goes
believe
up.
this actually just comes down to this and a
Yeah.
constant. Is my take, but I'll have to figure out how that actually works. Okay. But anyway,